How do you calculate heat absorbed using specific heat? Have you ever wondered how we can figure out the heat absorbed by a substance? It's a fascinating topic that connects to everyday experiences like cooking or heating water. Let's break it down in a simple way. To calculate the heat absorbed, we use a specific formula. The formula is Q equals m times C times the change in temperature. In this equation, Q represents the heat absorbed, usually measured in joules or calories. The letter m stands for the mass of the substance, which can be in grams or kilograms. The letter C is the specific heat capacity of the substance, which tells us how much heat is needed to raise the temperature of 1 unit mass by 1 degree Celsius or Kelvin. Finally, the change in temperature is represented by the symbol delta, which is the difference between the final and initial temperatures. Let's break this down further. First, the mass of the substance is important. If you have more of a substance, you will need more heat to change its temperature. For example, heating a large pot of water requires more energy than heating a small cup. Next, we have the specific heat capacity. This is a property unique to each material. Water, for instance, has a high specific heat capacity, meaning it takes a lot of energy to raise its temperature compared to metals, which heat up quickly. Now, let's talk about the change in temperature. This is simply how much the temperature increases or decreases. A larger temperature change means that more heat is absorbed. Here's a practical example to illustrate this. Imagine you want to heat 100 grams of water, which has a specific heat capacity of about 4.18 for joules per gram per degree Celsius. If you start at 20 degrees Celsius and heat it to 80 degrees Celsius, the change in temperature is 60 degrees. Using the formula, you would calculate the heat absorbed like this. Q equals 100 grams times 4.18 for joules per gram per degree Celsius times 60 degrees. When you do the math, you find that the heat absorbed is 25,100 for joules. This calculation is not just a number. It helps us understand how energy moves when substances are heated or cooled. It aligns with the first law of thermodynamics, which tells us that energy is conserved and can be transferred as heat or work. Heat flows from hotter objects to cooler ones, and this formula allows us to quantify those changes. By connecting measurable quantities like mass and temperature change to energy transfer, we make the principles of thermodynamics accessible and practical. This understanding is useful in fields like chemistry, physics, and engineering, as well as in our daily lives. So next time you heat something up, remember the science behind it.